Now this problem is a mix of function and number system. Now what is given to you is v of t minus 2 is equal to t square minus t. And what we have to find out the number of values of t such that the minimum possible value of the product of two distinct prime numbers divides v of t. So first we can understand that v of t could be calculated if we substitute, instead of t we can substitute t plus 2. So when you put t as t plus 2, it would become t, v of t, which is equal to t plus 2 whole square minus t plus 2. So if we solve this will come out to be t plus 1 into t plus 2. So we can understand that v of t is product of two consecutive numbers. Now my minimum possible value of the product of two distinct prime numbers has to be 6, which is 2 into 3 equal to 6. So we have to check that this number is divisible by 6 with how many values, where t lies in the range from 0 to 89. So product of two numbers will always be divisible by 2, correct? And if it is divisible by 3 as well, then definitely it has to be divisible by 6. Now what we can assume t as either a multiple of 3, it could be, or it could be 3k plus 1, or it could be 3k plus 2. Now when you substitute 3k, the number would become, v of t if I calculate, would become 3k plus 1, and this would become 3k plus 2. So definitely if you look over here, the number 3k plus 1 into 3k plus 2 is not a multiple of 3. So all such values where t is equal to a multiple of 3, the number will not be divisible by 6. So we'll not count the values which are multiples of 3 in the range 0 to 89. But when you substitute 3k plus 1, so what will happen? This will become 3k plus 2, and this would become 3k plus 3. Now 3k plus 3 is definitely a multiple of 3, which means if I divide this number, it would be completely divisible by 6. So we can take all the values of the form 3k plus 1 in the range 0 to 89. Similarly, when you substitute 3k plus 2, so the number would become 3k plus 3 multiplied with 3k plus 4. So again, if you look over here, 3k plus 3 would definitely be a multiple of 3. So this entire number 3k plus 3 into 3k plus 4 would again be divisible by 6. See, we don't have to check for 2 because it's a product of two consecutive numbers. It would definitely be divisible by 2 in any of the case. So what we can do is, we have to count the numbers 3k plus 2 as well in the range 0 to 89. So we can understand that out of those 90 numbers, 30 of them starting from 0, 3, 6 and so on, I'll have 30 values where I'm assuming the numbers of the form 3k starting k as 0 till 29. So my 3k would become 0, 3, 6 and so on till 87. So these 30 values I can subtract from 90. So my correct answer would be 60, which is your option number C.